And I love the product rule, but man, do I love the quotient rule. And the quotient rule is low-D high. Wait, hold on, wait. Low-D high minus, not plus, even though 6 of you were using a quotient rule with a plus sign in the middle of it on the trimester exam. Low-D high minus high-D low all over low. And we love the derivative of the square root of x. We know that one.
1 over the...
Derivative of the square root of x is 1 over 2 square roots of x, and the derivative of 1 over x is?
Natural log.
No.
Negative 1 over
Derivative of 1 over x
squared
is negative 1 over x squared, right, Martyr? All the folks that said natural log of x, they were thinking that the derivative of natural log of x is, what's the derivative of natural log, Martyr? Is 1 over x. Okay. That's great. I could, no offense, do not be offended by what I'm going to say next. I could train monkeys to do that. That's not what excites Martyr's like, but I still struggle with that. What does that mean? Don't worry. Like, that's great and all that you've got your product rule and your quotient rule and your chain rule and you got all these things. But like, when I was in graduate school, what I really got excited about was like using these things, like actually solving real world problems. There is nobody on the planet that has a job title of Chief Derivative Officer. Nobody has that job. If someone did, it could be me. No one has that job. It's about the applications. And so for the next 3 days, we are all about the applications. We are going deep into the applications. It's all about the geometry. If you ask Rogelio and Lucio and Brian and Victoria, this is where I broke them. And I had been thinking about this for the last 2 weeks, and I want to fix it. And I want to get it under control, and today is my do-over. So you all are my guinea pigs. I've never done this lesson before. I've never worked these problems with anybody before. It is going to go really, really well, and I'll have documentary evidence of this. So, before we even start on the application problems, let's start with some basic questions. Absolute maximum. What does that even mean? Let's get some hands on this. What is an absolute maximum? What does it mean? 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 No, Amy, what's an absolute maximum?
Highest point of the graph.
It's the highest point on the graph, right? It's the absolute highest point. Another word for absolute max is?
global.
Global max. But there are vocabulary words that you know of that mean absolute max. Words like greatest, most, highest. Right, these are all those superlative words that are going to like trigger in your brain, oh, absolute max. If I wanted you to find an absolute maximum value of a function, and you had no graph in front of you, what would you do? Don't tell me, talk to somebody near you. If I gave you an equation, I said, go find that absolute maximum value, what would you do? Have a quick conversation about it.
Tis on you guys.
Oh yeah, you're right.
You've never seen
Find the derivative of it and then put that equal to 0.
Alright, let's get some hands on this. How would you go about finding an absolute maximum value? How would you find it? What would you do? What would you do? Daisy, what would you do? Okay, so if I've got f of x on some closed interval AB, what would you do?
Get the endpoints.
So you'd find your endpoints. Okay, you've got endpoints at x equals a and x equals b, then what? You would just find the endpoints and you're done? Then what do you do?
You plug in the endpoints to the function.
Okay, so we're going to plug in, we're going to evaluate the endpoints, find f of a and f of b. I heard some other folks talking about the derivative. Right, like we're going to find the derivative. Why? 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 Jennifer, why do we find the derivative?
Because then it's going to give you the internal candidate.
Okay, so we find the derivative f prime of x to get those internal candidates, because those internal candidates, Christian, when you find the derivative, how do you find the internal candidates? What do?
You set the equation equal to 0.
You set the derivative equal to 0, but that's not it. That's not all the answers. That's part of the answers. What else do you do?
The derivative equal to, well, when it does not exist.
Okay, then we look to see where the derivative does not exist. Here, I'm thinking horizontal tangent lines. Over in the other case, I'm looking at cusp points. Because for any graph that I'm ever going to give you, it does not matter what that graph looks like. If I say on a closed interval, where's the absolute highest point? It either happens at an endpoint, or it happens inside where you have relative maxes, and relative maxes is where f prime changes from positive to negative, equal to 0, or in this case undefined.
Increasing to decreasing.
Where f changes from increasing to decreasing, but where f prime, that's why we look at the derivative, goes from positive to negative. Big picture, is everybody okay? Okay, so let's actually do an application problem. So excited about this. Okay, take a minute, read through this problem. All the math we have studied all year is coming into this one problem. I'm so excited. It's a high point of my day. So Mrs. Pandya and the Gardening Club are planning a new garden for the Southwest campus. How nice of them. They have a total of 32 yards of fencing available to place around the garden. They've decided to place the garden right next to a building in such a way that the building forms one side of the garden and no fencing is needed. Assuming they use all the fencing available, what are the dimensions of the garden that will guarantee the garden has the greatest area? This is what we're going to be doing for the next couple of days. There is no function that I have given to you. There's no equation. You don't have anything that you can graph. This is a real situation. I'm sure we can all imagine Miss Pandya actually coming to Mr. Newcomer and saying, I want more garden space. You can turn it off.
People need more.
So, what are the thoughts that are out there? What might you do? What could you do? I'll take anything from anybody. It doesn't have to do anything with calculus. Jonathan, what are your thoughts?
Using the diagram, maybe how many sides the garden.
Okay, how many sides does the garden have?
4.
The garden has 4 sides. Okay, what else? Nora?
But only 3 of the sides would be like fencing.
Right, I only need to put fencing over here, and over here, because she's being clever and she's using the building. What else?
We know since it's a rectangle.
Okay, it's a rectangle.
The 2 sides are going to be the same length, and the other 2 sides.
So these 2 sides have to be the same, and these 2 sides have to be the same if it's going to be a rectangle. What? I'll take any. There are no bad ideas coming right now. Adriana, what else?
Since they're asking you for the garden with the largest area, the function you could use would be length times width.
Okay, so we've got length over here, we've got width over here, and they're asking me about the greatest area, and so I heard you saying that you want to do something with area equals length times width. Any other thoughts that are out there? You know what I mean?
The 32 yards has to be within the 3 sides of the garden.
We've got 32 yards of fencing, and those 32 yards, what are we going to do with that? It has to go around, right? I'm going to use some fencing here, some fencing here, some fencing here. I could imagine giving this to 8th graders, no offense, and asking them to try to solve this problem. What would 8th graders do?
Divide.
Jasmine, what would they do? They would do some geometry. Let's be more specific. What would they do? 8th graders, given this problem, who know nothing about calculus, what could they do? Ron Bear, what could they do?
Divide 32 by 3.
They might divide 32 by 3 and say, this is the best solution. And if they did that, I would say, how do you know it is the best? Is this truly the best, or is there a better answer out there? And I would hope those 8th graders would say, I don't know, let me try some stuff. Maybe what they would do is they'd build a table of values and say, I'm going to let the width be 1 and 1, and the length is going to be 30. Maybe they say the width is 2 and 2, and the length is... If the width is 2 and 2, what's the length?
28.
28. Maybe the width is 10 and 10, and the length is going to be 12. And they go through this process of elimination. Here's what we're going to do as calculus students. I know I've got this area equals length times width, and this is what I want to maximize. Right? I want to make this as big as possible. What we're normally going to refer to this as is it's the objective function. But I also know I can't just pick any old length and width. There's a restriction. There's something that has to be true here. David, what do you know?
The left and the right side have to be smaller than the length.
So you think the left and the right have to be smaller than this? Maybe. There is something for sure that has to be true. Jasmine, what's the thing that has to be true?
There are only 3 sides.
There's only 3 sides, and how much fencing do I get?
32.
I get 32 yards. So if this side over here is W, I know that W plus L has to be exactly 32. We're okay? This guy here is what we're going to call the constraint. Right? I can do whatever I want in terms of length and width as long as it all adds up to 32. So maybe you say, all right, well, what I want to do is say that 2 widths plus a length is equal to 32. I know that my area is length times width. I know that 2 times the width plus the length has to be 32. What I want to do is I want to make this big. Right? I want to maximize. Which really means I want to go through this whole process. Right? Just like we were maximizing functions last night, I want to find the maximum of this guy. Which means go find a derivative. Set the derivative equal to 0. Figure out your endpoints, plug it in, that whole process. And there's a problem here. There's something that's happening here that has never happened before in our calculus labs. Just Jasmine? What's different? What's the problem here? What's going to get in the way of anybody in this room taking the derivative? Nora, what's going to get in the way? You've got 2 variables over here. You've got length and width. Normally when we find a derivative, everything's like in terms of x's or it's in terms of t's. That's where this constraint equation is going to come in. If you know that 2 times the width plus the length is equal to 32, what you can do, you can solve for L or you can solve for W, whichever one's going to make your life easier. Given a choice, I think it's easier to say that the length is 32 minus 2W. Are we okay? That's your constraint. 2 widths plus a length has to be equal to 32. So that's the same as saying L equals 32 minus 2W. Trust your instincts. If you know the length is 32 minus 2W, and the area, which is the thing that I want to maximize, is in terms of length and W, right? We can just plug in. So I can say that area is going to be 32 minus 2W times W. That's what I want to make big. I want to make this as big as possible. How do we go about doing that? How do you find a maximum? What have we been doing for the past few days? You don't set it equal to 0. Not yet. You find the derivative. You set the derivative equal to 0. If I want to find the derivative, I think I've got some options here. Some people are thinking product rule. Nothing wrong with doing the product rule. But I'm hoping that maybe some folks are thinking, you know, product rule is a little overkill here. Why not just do the algebra first, then do some calculus? So if I do that, then the area is going to be 32W minus 2W squared. Go find that derivative. What's that derivative going to be?
32 minus 4W.
Right, derivative of 32W is 32 minus the derivative of 2W squared.
4W.
4W. I found the derivative because what I really care about is where's the derivative equal to 0. So set the derivative equal to 0. 32 is equal to 4W, so W is going to be 8. W is equal to 8 causes the derivative to be equal to 0. But the other thing you guys normally look for is where is the derivative undefined? Where doesn't it exist? Is there a place where the derivative doesn't exist?
No.
Right, there's no denominators. There's nothing special. It's just a nice simple one. So this guy here, the fancy word for this guy?
candidate.
It's your candidate. It's that internal candidate. But I'm going to be really careful here. It's the candidate. This is where I might have a maximum. I haven't proven maximum. This is a might be kind of situation. The other places where I might have a max are the endpoints. Where are the endpoints? Where the heck are those endpoints? Are there endpoints?
Yes.
And here's like they're not going to tell you the endpoints. What do you think?
Yeah, 1 in 30.
Okay, if we're talking about W, there is a smallest width that you can have. And I heard Jasmine say 1. But if you're going to say that the width has to be greater than or equal to 1, then you're saying you can't have a width of like 0.5. And in terms of yards, you could have a really small side. In fact, we could say let's go all the way down to 0.
But then, you can't put equal to.
You could. I mean, if you go with 0, then you don't actually have a garden. You just have a line.
Yeah.
But let's allow 0 for right now. I think there's also an upper bound on the width. 32? Disagree with 32. I disagree with 32.
It has to be divided.
Look at this problem. Why am I going to disagree with 32? There's a really good reason where I'm not going to take 32. 32 is a popular wrong answer. Look at the diagram. Think about this situation. Marvin, why not 32?
There's 2 widths.
There's 2 widths, and I only have 32 yards. Right? So I can't say 32 over here and 32 over here. It's too much. What am I really going to say? 15? How about 16? I've got my endpoints. I've got my internal candidates. If I'm going to have a max, it happens at one of these 3 places. The last thing to do to figure out what is the actual maximum?
Evaluate.
It's exactly what you guys were doing last night for homework. You're like, oh, I've got my candidate. I've got my endpoints. The last thing to do?
Evaluate.
Evaluate. You're going to plug back into your objective function. So we're back to like the evaluate step. So I'm going to find what's the area if the width is 0. What's the area if the width is 8? What's the area if the width is 16? And the mistake I want to make sure you avoid, you got to go back to the area, not the derivative of the area. So if W is equal to 0, use either of these 2. They mean the exact same thing. One of them is probably easier to work with. I think the first one's easier to work with in this factored form. So I'm going to get, what is that, 32 minus 0 times 0. What's that area?
0.
0. No surprise. That's what Rambeer said earlier. If I make the width 0, I get no area. Why would you do that? If the width is 8, now I've got 32 minus 2 times 8 times 8, which I think is 32 minus 16. That's 16 times 8, which is 128. If I go with 16, I'm going to get 0. So I've got 0. The answer to the question. Make sure you answer the right question here. What are the dimensions of the garden with the garden which generate the largest area? What are the dimensions? Hold on, Rambeer. My options were let the width be 0, let the width be 8, or let the width be 16. The best option here? Right, this guy here is going to be your max. But the dimensions, your final answer, I would say the garden with the largest area has a, what is it, a width of 8 yards And what about that length? And a length of 16 yards. And that's it. That would be like the final problem, except all the pieces. We've taken this from start to finish. I'll take questions. Any question from anybody? What's up, Nora? And that's the beautiful part. For the next 3 days, we're in geometry and calculus. But if you look, if you really like step back, once we're able to take the word problem and set up the equation, it is all the stuff we've been doing for the past 2 days, but now there's like a reason for doing it. Yeah.
Can you explain how you went from L equals 32 minus W to the area? To the equation?
Okay, are you okay with where the constraint came from?
Yeah.
And then we use the constraint to isolate one of the variables. So if the length is 32 minus 2W, I can rewrite the area equation using just one variable instead of two.
Oh, okay.
And once we get to one variable, then life is good.
So if you were instead you solve for W,
Yep.
it'd be you have to multiply times W 2 times.
If you solve it for W, this is going to look a little bit different. The work that you do over here is going to look a little bit different, but you're going to wind up with the same answer at the end. Here's what I want to do. I want to give you guys the next 12 minutes or so to try 2 practice problems on the next page. It's the same kind of problem. It's still Miss Pandia and her garden. She still has 32 yards, but what I'm going to do in each of these problems is change the problem enough, change the situation to see what you can do with your smarticle particles. You've got 12 minutes before we try a really fun problem. Okay. And whoever is the tallest person in the group, you're in control of the cups. Sorry. I'll have to get more original. I'm so excited about optimization. Tall person gets the cups.
Wait.
It's on you guys again. Oh, falling.
Only when she pointed it at you. That's when it broke.
It's scared of me. It should be
No,
scared
it's
of
not
me.
Robbie.
Wait, who's the one?
Okay. We're working. Yeah.
This time the garden club is going to use 2 buildings to form the sides of the garden. How much greater is the area of the new garden?
But we're not using
Oh, let's solve the problem again.
so we use that fact when we first Right.
Yeah, I can. Because I think I'm.
The key with all these problems is going to be make sure you understand it.
It's going to be length plus width equals 32.
And we want the greatest area.
I thought it was 16 times 16.
What did you say, 16?
Yeah, they ain't that weird.
So wouldn't the area be the same? No, oh no. Now it's 2 sides.
So for width, I guess,
You got good thoughts here.
I know, that's what
And that's great. That's a big thing. In that it's a good idea. Right. Because we're not necessarily talking about a square. Maybe you're right. You're wrong. But it's in calculus where you consider all the possibilities. Let me consider all the widths. It's the calculus that's going to your
I'm in a the fact that I was born
the length of your straight. What? The objective function is the same because that's the one thing the area.
Okay.
But now this part's going to be different.
16 by 16 is not 32.
Friends over here, how we doing?
No, 16 plus 16.
Oh,
Yeah, but you're talking about the area.
Oh, I'm talking about yards. There's 32 yards.
And I definitely want you guys to
I don't know, because I figured since you just covered up another width.
But you're telling me the width and the length are gonna be the same size?
Yeah, a rectangular
The
piece.
width and the length?
So there is some good 8th grade thinking happening.
It's gonna be one
See,
next W.
I will tell you, he is 100% right.
But you don't want us to do that.
Well, you're right, but you aren't proving it to me.
Yeah.
You might be right. You can't know for sure that you're right unless you do what Nora's doing here and saying, okay, well, let me consider all of
And I
these.
got A
Let me
equals
consider
32
the
W.
length can be anything, the width can be anything, but I know when I add them together, it has to be 32 yards. Okay, the vocabulary here, L plus W equals 32, that's your constraint.
Derivative, I got
The area equals L times W, that's your optimization. And so you're going to use the constraint to rewrite the optimization in one variable, take the derivative.
32 times 3.
But the final proof, though, is going to come in by finding those internal candidates and evaluating the original function at the candidates and the endpoints.
Yeah. I was gonna ask you about the endpoints, because like obviously like the
I hear you.
endpoints here,
And I also
here,
got 32.
yeah,
Yes, because now, why are they different?
because now there's like there's another side that you don't have to deal with.
Right, one of the other sides has been taken out of the problem form. Yeah. Hello, friends. How do you, okay, yes. So there's going to have to be some like real
Oh yeah,
world
because you
knowledge.
don't subtract, it's not addition.
Which is why I
So we
needed
just
that.
divide by 32. What
So
does that
you're
mean?
saying that your internal candidate is 16. I 100% agree with that. But you also have to, what are the endpoints?
It could be a possible 16 and then L equals 32 minus W.
Is there a biggest width?
You can't be
I think it was 32 minus W, yeah.
Smallest.
That's 32.
Oh wait, no, it's 32.
And I think we know what
We
happens.
didn't bring down the minus sign. Okay. It's not zero.
You get nothing. But there's also
trying to 32 So 32 times W is minus 32.
No. It's just 32 times
32 yards.
Basically, you just do the power rule. Basically. So you
It's not accurate.
break down the two. So it's 2W.
Yes, because the longest side is
Okay, yeah, 2W. Okay, yeah. Okay, and then
How do you come up with your
No.
endpoints? That's what I'm trying to figure out. It should be a lot smaller. Should it be bigger? It should be bigger.
She could do 20 yards or 12 yards
16.
because she has that full 32 yards to spend on this any way she wants.
So I'm thinking about the
16.
So the reality is
maybe I
that
can win and be 0 to 8.
but
because it's only one side, we're not dividing by 2 this time.
The what?
Okay, talk.
Honestly, the only thing is messing up is the
I
endpoint.
guess it would be from 0 to
Because you found the endpoint here, because you're dividing what, 32? Divide by 2? Because there's 2 W's. So
Units. Units. What you got? You right?
But you found, you evaluated because it has
They were different sides, they were different lengths. L has to be
So we
greater
got the
than
candidates.
both.
You're divided by 2.
And we've got.
Yeah.
So I don't know where you got
Why?
Right, usually in these real world
because, like,
problems,
that's
the
the-
endpoints. Here, look here. There's gonna have to be some like real
even
world.
though it's not like
Yeah, I think it's 16.
Just leave it like that.
So then you plug
So
in.
where's the maximum 32?
Just him.
The question I'm asking.
Yeah, Mariah.
Stop me. Hi. I can't wait to play this video back for your parents. It's gonna be great.
Wait, no, please don't.
Wait, what does the rest mean?
They are not gonna be from 0 to 16, and they are for sure
That were
not
like
gonna be.
crying. That were crying.
No on the X. Hi, what's up?
We can't figure out the endpoint, like how exactly do you find like the endpoint? Because I know like here you divide.
So hopefully the calculus itself is comfortable right now. And the hard part is these endpoints. Okay, I was not expecting the endpoints to be the hard part. The endpoints are going to come from like real world knowledge. I wanted to give you guys something concrete that you could work with here. if you're doing everything in terms of W, you're saying W equals 16 is the internal candidate, then you want to ask the question, what's the smallest the width could be? What's the biggest the width could be? What's the smallest width she could ever consider in this problem?
Zero.
Zero. Now that's a stupid example.
Yeah, that was an easy part.
So now flip the question. What's the biggest the width could be?
16. I think it is.
No, we didn't. 31.
31, 32. Could she make the garden 20 yards wide and 12 yards long? Right, she can spend her 32 yards of fencing that way, 20 yards and 12 yards. Could she go 31 yards in 1 yard?
Yeah.
Yes, but 31 is not the end point. I understand what's happening. You guys are thinking like whole numbers. You're forgetting that she could go 31.9 yards by a tenth of a yard. Why would you ever build a garden that way? I don't know. But we have to accept that it doesn't have to be whole numbers. It doesn't have to be integers. It could be 31.9999 yards by a thousandth of a yard. It's just that the width and the length have to add up to 32 all the time.
So our endpoint
Are
31, 0 to
0.
less than or equal to W, which is less than or equal to 31.9.
That we're just going to say 32. We're going to let her go all the way out to 32.
They're gonna put fencing.
Why would you say 32? I know.
I care greatly about units.
Every time I ask
Greatly care about
how
the
do you do
units.
this one?
Yeah, 3
Nine.
5.
Somebody.
Then it's 0.
Right, so he has to
Eight
get
is
the biggest possible value W.
What? You're going back to the... No, I said because then you go halfway.
Right now the building is now
Wait, so we plug in each of them to the original function, not to the derivative.
So clever.
Yeah,
So
the original function.
What is 32 minus 16 times 6? What's 16 times 6?
28.
Call this whole thing W.
428.
So it's 0, 16, and 36.
So you could go with this 4W plus
I mean,
10.
oh, 16 times.
Get out of here.
Get out of here. Just so sure you're like, whatever. 100.
Can we use calculator?
Are you the tallest?
How
Wait,
much
what is
greater
it?
is the area?
It's 256.
Evaluate. So it's twice as big. Yeah, it's just twice as big.
Totally your choice. What's going to be different though is if you say, and Kimberly's on the same topic.
So how much we
She's
break
calling
it?
this little piece W.
I got
Then when
8,192.
you talk to me about W, W is
32 times W
and
times
so
W.
if you say W is 5. But you're thinking, no. This is W. You're going to call W 10.
Oh, it's
That's
minus
fine,
W?
Because I'm reading along the full process.
I'm done.
Oh, by.
Okay. So it's 32 minus 30.
Because I've solved this problem 100 years ago.
How is it negative?
Because 32 minus
16 is 16.
32 times 16 minus 12. I didn't say that.
It's really hard.
Is that like natural?
Why didn't I care? 256. Sorry. I don't know why my calculator gave me a negative
Mr. D,
number.
Yes, sir.
how do you get the title of being a mathematician?
Are you mathematician?
Give it to yourself.
Okay.
Wait,
Oh, that's
that's a so.
Yeah, that was something more
Oh,
official.
is that a self-proclaimed title?
I love math in ways a lot of people don't. I think that's what gave me the title mathematician.
16?
So you're a
Alright.
mathematician.
Alright, so I am pretty convinced from going around that just about everybody has got this process under control right now. Okay, I'm picking right now friendly problems that are going to be comfortable for you. It is day 1. I don't want people crying on day 1. I want to save that for Monday. Okay? So, final answer, absolute maximum area is 256 square yards, which is 128 square yards greater than before. I saw that on just about all the papers. It is very likely that you might be sitting next to someone that says L plus W equals 32, and somebody else says, no, I'm going to use X and Y. That's fine. You might be sitting next to somebody that said L equals 32 minus W, and somebody else says W equals 32 minus L. That's fine. With 21 people in the room, I would expect a variety of approaches. But no matter how you approach it, your final answer is going to be the width is 16 and the length is 16. How many of you guys honestly had width is 16, length 16? Okay, good. Now this problem, I had nowhere on my radar screen, nowhere this morning when I wrote this question, was I thinking about calling this piece W and this little piece W. But Kimberly and Jonathan did that. They said W, 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 L, and L. And that's okay. Your constraint then will say 4W plus 2L equals 32. Some stuff will work out differently over here. But at the end of the day, the best solution is when L, was it L? L is going to be 8. So it's going to be 8 yards this way, 8 yards this way, 8 yards this way, 8 yards that way. And that works. Lots and lots and lots of options. Tonight's homework, you're going to do 3 of these. We've still got almost 15 minutes left. Don't worry. Adriana's like, no, it can't be time. You're right, it's not. So there's, on the final page, there's 4 problems. I want you to pick 3. Truly, the process that we worked on yesterday and the day before is how you're going to go about solving all of these problems. If they're word problems, don't let the words hold you back. For those of you that can stay after school with me, if you just want to come here and work on these problems, get them done, that's great. Because now I really want to push your thinking. All right, so let's go over to what is going to be the hardest problem we do, at least today, possibly in the next 3 days. Christian, can you read that problem?
A rectangle is inscribed in a semicircle radius 4. Determine the area of the largest such rectangle.
There you go. That's the problem. That's the problem. It's like the fewest number of words I could think of, and this is going to be a really hard question. I want you to have a strategy conversation with somebody near you. What are you going to do to start this problem?
A rectangle is, draw a diagram. Rectangle is inscribed in a, so the rectangle is inside the semicircle? Radius of 4. So that means that the length has to be 4. But
diameter will be the whole thing.
right, but the length of the rectangle will be 4.
Inscribe just means inside and touching. Inside and touching.
Before the radius is 4.
But like if you do it, the rectangle will be like in the middle of that.
Yeah, that's
What? Doing it wrong?
Wait, it's the same thing. That's the same thing.
Wait, mister, wouldn't it depend on how you look at it?
All right, for those of you that need a visual, one is coming.
Yeah. Because I usually do it like 4 different ways.
Because like the
Rectangle.
All right, friends, if I can get everybody to stop just for a second. That's the situation that we're looking at.
Yeah.
We've got a semicircle and a rectangle on the inside. And if you're sitting with Noemi and Edgar and Christian, you guys have like some really good seats here. Here's the situation. I want to build this rectangle so that the area is greatest. So for this particular x value, let me look over here. If I move the x value, do you guys see how the height's changing? Mm-hmm. Right, x value becomes smaller, the height becomes
Greater.
Taller.
the height gets to become taller, right? It's not as wide as before. What's happening to the area though?
Decreases.
The area decreases. So let me make the x value a little bit bigger. Is that the biggest rectangle?
No.
Is that one?
No.
So that one?
No.
That one?
No.
I love this game.
To the right, to the right.
Oh, if only she was here.
Keep going.
Tell me when to stop. Tell me when to stop.
Go.
Until.
Just keep going.
Oh, it's deep.
Like I should go all the way out. All the
No.
way out.
No. Wait, go up.
Where is it?
There.
15,
Right there.
15 something.
Somewhere there.
15.
Right. Okay. Good.
16.
Oh,
16.
you guys are so goofy. Okay. somewhere in this neighborhood feels like it's going to be best, right? No 8th grader is going to do this. No 8th grader is going to do this. This is why I get called in. Right? I get called in as a consultant to help you guys with like the big stuff. So here's what I want to do. Let's do the real calculus. So the situation is we've got a semicircle. Here's my semicircle. And I've got a rectangle. I'm just going to draw my little rectangle. I saw this on most papers. What I need two things. I need a constraint equation. And I need, what was the other fancy word?
Objective function.
You call it the objective function or you call it the optimization function. They mean the same thing. There's something that I want to make really, really big. And the thing I want to make really, really big is... Oh, awkward. Go back and read the problem. What do I want to make big?
The area.
That area. So my optimization or my objective function is the area. There's usually a constraint as well. The constraint is going to be the thing that links everything together. I'm going to call this distance from the x-axis x, and I'm going to call the height of the rectangle y. So my objective function, the area that I'm trying to make as big as possible, what's the objective function going to be? I hear x times y in a lot of places. I'm hearing 2x times y.
Why did you draw it like that?
Because I wanted to take advantage of the symmetry that comes along with the semicircle.
Yeah, it's 2x.
It should be 2x, because if I'm going to call this guy over here x, then I'm also going x in this direction. So my area is going to be 2x times y. Now the constraint, this is not something I would expect you guys would just drop on the spot and get it correct. The constraint is that this point over here, the height, always has to be on the circle. Always, always, always has to be on the circle. I'm not going to go beyond the circle, that would be too tall. I'm not going to stop down here, it wouldn't be inscribed. It's got to be right here. And I told you guys something about the circle.
The radius.
I told you that the radius is 4. Depending on how well you did with conic sections last year, you might remember the equation of a circle. You may not even remember that you studied something called conic sections. But here's what I know. I know that the radius starts out here and goes out here to any point on the circle. And so that's 4 there. So I get a triangle. I don't just get a triangle. I get a right triangle, and because I have a right triangle, my best friend in the whole wide world that I met in 8th grade, the Pythagorean theorem. I don't know who you guys met in 8th grade, but I know that Pythagoras says x squared plus y squared equals 16. I've got my area, I've got this guy over here. What I want to do is I want to take the derivative, and you guys know what the problem is. Right? I cannot take the derivative of this formula here, 2xy, because? 2 variables. That's when you go to the constraint. You say, oh, this is my constraint, solve for one of the variables. I don't care which one you want to solve for. I'm going to solve for y. So y squared equals 16 minus x squared. Y is going to be plus or minus the square root of 16 minus x squared. And what I know, because of the way I made my semicircle, I'm not even going to consider the negatives. I'm only going to look and say that y is the square root of 16 minus x squared. I know I went a little fast there, but it's really just algebra. Why did we do that? Why did we do that?
Which one?
Why did we just solve that equation for y? Marvin, why did we do that?
So that we only have one variable.
Wait, we only have one variable? Where?
So we can plug it in.
You've got to go back to your objective function, and you want to write the objective function using one variable. So instead of saying that a equals 2x times y, I'm going to say a is 2x times the square root of 16 minus x squared. Oh my God, so excited. I have an objective function in one variable. Guess what?
Find the derivative.
Find the derivative!
No, pues,
Find the derivative! Jennifer, how are we going to find the derivative? How are you going to find the derivative of this guy here? You need the product rule. You don't just need the product rule. Abraham, what else do you need? Chain rule. Chain rule. So I take the derivative of the first, which is 2. I leave the second one alone. Plus, I leave the first one alone. And now I take the derivative of the square root of 16 minus x squared. And that's a chain rule. The baby is 16 minus x squared. The mama is the square root. And that derivative, you got it, 1 over 2 times the square root of 16 minus x squared times negative 2x. I'm going to clean this up a little bit to say it's 2 times the square root of 16 minus x squared. 2x times 1 times negative 2x is negative 4x squared over 2 times the square root of 16 minus x squared. We're not going to be able to finish the whole problem, but we're going to get close. So, that's A prime. I'm going to assume that everybody's okay with getting to A prime. Now what?
Set it equal to 0.
You found the derivative, and the reason that you found the derivative is to find horizontal tangent lines and
Cusp point.
cusp points, right? Where the derivative doesn't exist. So the question is, where is A prime equal to 0? If A prime is 0, then that means 2 times the square root of 16 minus x squared minus 4x squared over 2 times that square root of 16 minus x squared is equal to 0. Did we talk about my running in the gangs? And my nickname in high school in the gangs? Not doctor, but thank you. I'm flattered.
You were, wait, I know this. Fractionist.
Fraction killer. I was a fraction killer. If I want to get rid of the yes, the little white boy from Massachusetts. Okay, fraction killer. Nobody saw me coming. Okay. Multiplied by the common denominator, which is 2 times the square root of 16 minus x squared. You might be having nightmares, but just watch your fraction killer powers. Watch what's going to happen. 2 square root of 16 minus x squared times 2 square root of 16 minus x squared. 2 square root of 16 minus x squared times another 2 square root of 16 minus x squared is 4 times 16 minus x squared. Minus 2 square roots of 16 minus x squared times all this stuff over here.
Minus 4x squared.
Minus 4x squared, because the 2 square roots of 16 minus x squared in the denominator cancels with the 1 in the numerator. Oh my God, look at that. No more square roots, no more denominators, no more problems. So you get 64 minus 4x squared is equal to 0. 64 minus 8x squared. I mean, this is just a little bit above Algebra 1, so I'm not going to go too slow here. So I've got 64 equals 8x squared. Divide by 8. 8 is equal to x squared. X is plus or minus the square root of 8. These guys here, what's the name for them?
Internal candidates.
These are your internal candidates, but it's not all of them. Because you also have to figure out where is A prime. Where does A prime not exist? Look at your derivative. The only way that the square root doesn't exist is if that denominator is equal to 0. So you've got 2 times the square root of 16 minus x squared is equal to 0. Some of you might be able to just look at this and know what the answer is. Hold on. Divide both sides by 2. Square it. Where's 16 minus x squared equal to 0?
0.
Where's 16 minus x squared equal to 0?
4.
4 and negative 4. Right? Okay. I know we're not done with this problem, but the final steps here?
Evaluate.
Well, you're going to first of all identify the endpoints. And your endpoints are going to be what's the smallest x can be. What's the smallest that x value can be?
0.
0, what's the biggest?
A minus.
What's the biggest it can be? Look at the diagram. You have to stay on the semicircle. So the biggest is 4. Your candidates, you said, are x equals plus or minus the square root of 8 and x equals plus or minus 4. It looks like you have 4 candidates on the inside, but guess what? No negatives. And 4 is not actually an internal candidate, it's an endpoint. You have one endpoint. You've got x equals positive square root of 8, you've got x equals 0 and x equals 4. Those are the ones that you're going to test. There is nothing on tonight's homework that is this hard. But if you were able to stay with me even for 50% of this problem, you're in a great place. And if you're in a terrible place, I'll see you right after school.